This is Unit 4, Lesson 12, and this is Activity 4, Milkshakes Revisited. Now, Activity 1 was about the milkshakes that Diego was drinking and Jada was drinking. So now Jada wants to finish her milkshake faster than Diego, so she's going to speed up a little bit. If you remember in the beginning, she drank her shake at 1/4 of an ounce per second. She's actually going to speed up to 1/3 of an ounce every second. Diego was at 2/3 of an ounce per second. And I'm going to add another rate, which is 2/5 of an ounce per second. This is the rate at which Jada will finish at the exact same time as Diego. And we'll go through how that works in a few minutes. But it's useful to know that if you see 2/3 of an ounce per second, you can rewrite this relationship as 2 ounces per 3 seconds, or 1/4 of an ounce per second. That's the same as 1 ounce every 4 seconds, 1 ounce every 3 seconds, and 2 ounces every 5 seconds. So why is that? Why does that happen? Here's one example. So let's look at Diego's. We'll go through each of these rates, but let's look at Diego's rate first. So he drinks his shake in 2/3 of an ounce per second. So if we go out 3 seconds, so each of these are 2/3 of an ounce. It's 2/3 of an ounce. That's 1 second. 2/3 of an ounce. That's 2 seconds. 2/3 of an ounce. That's 3 seconds. 1 second, 2 seconds, 3 seconds. And how much did he drink? He drank 2 ounces. So that's 2 ounces in 3 seconds. And so here's some math that supports that. If he drinks 2/3 of an ounce in 1 second, well, 3 seconds, and you multiply that times 3 seconds, that's 3 times 2/3. These 3's cancel out, you end up with 2 ounces. You can also multiply 2 times 3 is 6. 6 divided by 3 is 2. You can get it that way. So 2/3 of an ounce per 1 second is the same as 2 ounces per 3 seconds. This is useful to understand when you draw the graphs. You can use both of these relationships to help you draw the graph. So let's look at for the other 3 rates. So Jada's rate of 1/4 of an ounce per second. So here's 1 second, 2 seconds, 3 seconds, 4 seconds. So it's 1, 2, 3, 4 seconds to drink 1 ounce. So it's 1 ounce in 4 seconds. And again, the math to support that, if it's 1/4 of an ounce in 1 second, then 4 times that is 4 times 1/4 is 1 ounce in 4 seconds. When Jada speeds up, that's 1/3 of an ounce, a tiny bit more, 1/3 of an ounce per second. So in 3 seconds, 1, 2, 3, she's going to drink 1 ounce. So this is 1 ounce per 3 seconds. So 1 second, 2 seconds, 3 seconds, she drinks 1 ounce. So again, the math, if she drinks 1/3 of an ounce in 1 second, multiply that by 3. So in 3 seconds, she drinks 1 ounce. 1/3 times 3 is 1. And finally, 2/5 of an ounce in 1 second. Well, go out 5 seconds. 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. That's 5 times 2/5. So 5 times 2/5. These 5's cancel and you end up with 2 ounces in 5 seconds. So 5 seconds, she drinks 2 ounces. So you start with 2/5 of an ounce in 1 second. You can rewrite that as 2 ounces in 5 seconds. So 2/5 of an ounce in 1 second times 5. So 2/5 times 5 equals 2. Again, you can multiply the 2 times 5 is 10. 10 divided by 5 is 2. So these are useful relationships to use as we draw the graphs. Before we get to the graphs, take a look at what's happening as Diego drinks his drink compared to Jada as she drinks her drink at 3 different rates. Now, Diego starts out with 20 ounces. So if you count these ounces here, 1, 2, you'd get 20 as you count this column. And Jada each time starts out with 12 ounces. So if you counted the ounces in Jada's columns, you'd end up with 12 ounces for each of these columns. All right, so let's see what happens. And let's compare Diego drinking at 2/3 of an ounce per second. That's his rate every time. But let's compare that to Jada drinking her drink at 1/3 of an ounce per second. So that's half as fast. She drinks 1/3 of an ounce. Diego drinks 2/3. So 1/3, Diego drinks 2/3. 1/3, Diego drinks 2/3. So notice he's finished 2 ounces in the time that Jada drinks 1 ounce. So he drinks twice as fast. He finishes twice as much. So 4 ounces, she has drank 2 ounces. This is the column for 1/3. 10 ounces, no, I'm sorry, 6 ounces, she's drank 3 ounces. 8 ounces, 4 ounces. So if you go all the way to the end, where they catch up, actually, let's go right to here. So this is where they have the same amount left to drink. So Diego has drank 16 ounces. If you count these up, it's 16. And Jada has drank 8 ounces. So she has 4 more ounces to drink. They both have 4 more ounces to drink. But Diego's going to drink his 4 ounces twice as fast. So now she has 2 ounces left to drink, and she's drinking 1/3 of an ounce per second. So for 2 ounces, that's 6 more seconds. 1, 2, 3, 4, 5, 6. All right, that's comparing 2/3 of an ounce per second to 1/3 of an ounce per second. So now let's compare Diego's drink 2/3 of an ounce per second to 2/5 of an ounce per second. That's out here. So there are 32 thirds in 20 ounces. So if you take 20 ounces and divide that by 2/3, you're going to find out that that answer is 30. And I'll show you that calculation a bit later. So 20 divided by 2/3 equals 30. That's why it takes 30 seconds. Likewise, 12 divided by 2/5 over here is also 30. So there are 32 fifths in 12. And there are 32 thirds in 20. So therefore, they are going to finish at the same time. So every second, Diego drinks 2/3. Every second, Jada drinks 2/5. So watch what happens. They're going to finish at the same time. So 2/3, 2/3, 2/3 compared to 2/5, 2/5, 2/5. And so they finish in 30 seconds, both of them. And then again, if Jada were drinking at 1/3 of an ounce per second, she would take 6 more seconds. And finally, let's look at what happens when Jada drinks very slowly. So here's 2/3 of an ounce, 2/3 of an ounce, 2/3 of an ounce, 2/3 of an ounce. So this is 4 seconds, and Jada has drank 2 ounces and 2/3. So these 2 ounces and 2/3 more. So that is 4 seconds. This is, let's go back. 1, 2, 3, 4. So in those same 4 seconds, Jada only drank this is 1/4 of an ounce per second. Jada only drank 1 ounce. So 4 more seconds. Jada drinks 2 ounces. Diego drinks 1, 2, 3, 4, 5, and 1/3 ounces. 4 more seconds. Oops. Jada has drank 4 ounces, and Diego has drank significantly more. So they pass right about here, somewhere between 19 and 20 seconds. They have the same amount left. We'll figure out what that is exactly. And Diego's going to finish the same amount remaining, but Diego's going to finish much faster than Jada. So in 30 seconds, 30 times 2/3 is equal to the 20 ounces that Diego drank, but 30 times 1/4 is equal to 7.5 ounces that Jada drank. 1, 2, 3, 4, 5, 6, 7.5 ounces. So she has 12 ounces. She drank 7.5 ounces. So she has 4.5 ounces left. 1, 2, 3, 4.5. So that is 18 fourths. 4 times 4 is 16, 17, 18. So it's going to take her 18 more seconds from 30 to 48 to finish. To write the equations for both Diego and Lynn. Remember that Diego is the same as before, so he's starting with 20 ounces and he's drinking his drink at 2/3 of an ounce per second. Lynn is starting with 12 ounces and she's drinking her drink at 1/3 of an ounce per second. That's faster than before when she was drinking at 1/4 of an ounce. Now she's drinking at 1/3 of an ounce. So to write the equations, the rate is written as a negative value because this is 2/3 of an ounce per second, but that 2/3 of an ounce every second is being subtracted from the beginning 20 ounces. So this is written as a negative rate. So x is the time in seconds. Y, 20 ounces is the y-intercept. It's the beginning of amount that Diego's starting with. So this is the form of the equation. This is the slope-intercept form. So m is the slope. In this case, it is a negative 2/3. And the beginning amount is 20 ounces. And that's the y-intercept. That's on the y-axis. Diego's beginning amount at 20 ounces. For Lynn, she's drinking faster than before. She's drinking at 1/3 of an ounce per second. Before, she was drinking at 1/4 of an ounce per second. So if you change both of these to twelfths, that's 3/12 of an ounce per second before and 4/12 of an ounce per second now. So that's 1/12 of an ounce per second faster. So let's take a look at those animations and see what happens between comparing 1/4 of an ounce to 1/3 of an ounce for 12 seconds. Because what this means is in 12 seconds, Lynn will drink 1 ounce more at the faster rate. So here are the animations. So this is 1/4 of an ounce per second, and this is 1/3 of an ounce per second. So if I go out 12 seconds, remember it's 1/12 of an ounce per second times 12 is going to be 1 ounce. So in the slower case, Lynn drinks 3 ounces. When she drinks faster, she drinks in that 12 seconds 1 more ounce. So it's right here. So instead of 3 ounces, she drinks 4 ounces. Now this happens 3 times because she's drinking 12 ounces. So the second 12 seconds is 24 seconds. So now she's 2 ounces ahead. So every 12 seconds, she drinks 1 more ounce. And so at the end, the third 12 seconds, which is 36 total seconds, she's 3 ounces ahead in the 1/4 of an ounce per second rate. She has 3 more ounces to drink. That is 12/4. And so it's going to take her 12 more seconds to finish her drink when she drank at the slower rate. So 12 more seconds, that gets her out to 48 seconds to finish at the slower rate. So Lynn is drinking at the faster rate, 1/3 of an ounce per second, but it's a negative 1/3 because every second 1/3 of an ounce is being subtracted from this 12 ounces. The y-intercept is the beginning 12 ounces. And in the slope-intercept form, the slope is a negative 1/3. And the y-intercept is her beginning amount at 12 ounces. So notice that Lynn is drinking her shake at half the rate as Diego. She's drinking her drink at 1/3 of an ounce per second, and Diego is drinking his drink at 2/3 of an ounce per second. So 1/3 is 1/2 of 2/3. 1/2 times 2/3 is these twos cancel. You're left with 1/3, but you can see it. You have 2 of these things called thirds. Half of that is 1 of those things called thirds. So to finish at the same time, Lynn must have half the volume, which would be 10 ounces. Or Diego can have twice the volume, which would be 24 ounces. Either way, it's the same. She has more than half the volume. She has 12 ounces. So she's going to finish after Diego. So even though she sped up her rate of drinking, she's still going to finish behind Diego. To graph each equation, it's useful to look at this rate, a negative 2/3 ounce per second for Diego, as 2 ounces, or actually that's a negative 2 ounces for every 3 seconds. So each grid line for time is 2 seconds. So Diego drinks 2 ounces in 3 seconds. 1, 2, 3. 2 ounces in 3 seconds. 1, 2, 3. 2 ounces in 3 seconds. 1, 2, 3. And it's also useful to look at the total amount of time it takes Diego to drink his drink. So he drinks 20 ounces. So that means he has 0 ounces left down here. So how long does it take him to drink those 20 ounces? We'll set this to 0. So all the 20 ounces is gone. And the amount of time it takes to get to 0 is a negative 2/3 times that time plus 20. So this becomes a positive 2/3 times the time, because you can add the additive inverse here. So a positive 2/3 x, and you're going to end up with 2/3 x on the other side. And what this says is 2/3 of some number equals 20. Well, 1/3 of that same number is equal to 10, half as much. And that means if 1/3 is 10, then 3/3, the whole number, is equal to 3 times 10, or 30. So 20 is 2/3 of some number. So take that 20 divided by 2, that's going to give you 10, so that's 1/3. And 3 of those thirds, or 3 times 10, equals 30. 10 is 1/3 of that same number. So down here, the total amount of time it takes Diego to drink his drink is 30 seconds. So then you can connect those points and you have your graph. The same thing with the slowest rate for Lynn, which was 1/4 of an ounce per second. So that's a negative 1/4 ounce per second. So that's a negative ounce, 1 ounce every 4 seconds. So this is 2 seconds, 3 seconds, 4 seconds. 1 ounce, 2, 4 seconds. 1 ounce, 2, 4 seconds. So you can graph each of those points and just connect them. But it's also useful, once again, to figure out how long it takes her to drink her 12 ounces. So that's when the volume is 0. So set this volume to 0. So the 12 ounces is gone. How long did that take? It took a negative 1/4 times the amount of time plus 12, her 12 ounces that she started with. This becomes a positive 1/4 x. So you add the additive inverse to both sides. And it says 1/4 of some number is equal to 12. So 4 times that number, 4 times 12, is equal to that number. And so 4 times 12, 12 is 1/4 of some number. So you can actually look at it this way. 12 divided by 1/4, how many 1/4s are in 12? Well, that's the same as 12 times 4. A little bit confusing here, but you just have to keep going through it to get used to working with the fractions. So 12 times 4 is 48 seconds. So 1/4 of some number is 12. That means that number, think about that for a moment, that number, which is 48, 1/4 of 48 is 12, or 4 times 12 equals 48. For the faster rate, again, 1/3 of an ounce per second, that's a negative 1/3 of an ounce per second, so it's a negative ounce every 3 seconds. So 1 ounce, 3 seconds. 1 ounce, 3 seconds. Remember up here it was 2 ounces in 3 seconds. It was twice as fast. So 1 ounce, 3 seconds, right here. And also, once again, the same idea. But I did this one a little bit differently in that I know she has 12 ounces to drink. It's 1 ounce every, it's 1/3 of an ounce every second. So how many 1/3s are in 12? Well, 12 divided by 1/3 is equal to 3 times 12 is equal to 36 seconds. So how many 1/3s are in 12? How many 1/3s are in 1? Well, 3. So 3 times 12 is equal to and why 12? That's the total amount that she's drinking. So 3 times that 12 is 36 seconds right here. And here's the equation. It's a negative 1/3 x plus 12 ounces, the beginning amount. And finally, I added this last rate. So I wanted to know, well, how fast does Lynn have to drink her drink to finish either before Diego or at the same time? Well, that's 12 ounces in 30 seconds. So you simplify this 12 ounces per 30 seconds. That simplifies to 2 ounces in 5 seconds, which is the same as 2/5 of an ounce per second. So this is useful to be able to go back and forth between 2 ounces for every 5 seconds. That's the same as 2/5 of an ounce per second. This is the same as, by the way, of 12/30 ounces per second. 2/5 of an ounce per second. So how many 2/5 are in 12? Well, 12 divided by 2/5. 12 total ounces to begin with. So 12 divided by 2/5, multiply by the multiplicative inverse or the reciprocal. So take that 12, divide it by 2. That means that 6 is 1/5, and you have 5 of those. 5 times that 1/5, or 5 times 6, is 30 seconds. So they both end at 30 seconds. And so now the idea is to figure out what these intersections mean. These are the points at which both Diego and Lynn have taken the same amount of time, and they have the same amount of milkshake left. So in this case, they've taken this same amount of time, which is 19 2/10 seconds, and they both have 7 2/10 ounces of milkshake left, but since Diego's drinking faster, he's going to finish before. In this case, this is a faster rate, so it takes Diego longer to catch Lynn. So he catches Lynn down here at 24 ounces. They both have 4 ounces left to drink, but Diego's drinking faster, so he finishes his drink before Lynn finishes hers. And finally, if they for 2/5 of an ounce per second, that's faster yet, so it takes Diego a longer time to catch Lynn, and he actually catches her right when he's finishing and right when she's finishing. So they both finish at the same time. So here are the 3 equations. So to figure out these intersections, these points of intersection, this point where the 2 graphs intersect, what that means is they have the same volume of milkshake left. So in this case, it's 7 2/10 ounces, and they've been drinking for the same amount of time, 19 2/10. So how do you figure out these 2 coordinates? Well, you know that the volume remaining is the same. So you set these 2 equations equal to each other, and you solve for the amount of time. So here are the 2 equations. So negative 2/3 ounces per second, or negative 1/4 ounce per second, beginning with 20 or beginning with 12. And you know that at some point in time, they have the same volume remaining because Diego has finally caught Lynn. So to figure out what that time is, set them equal to each other. So now they have the same volume remaining. So now they're equal to each other, and you solve for that time. So you go through, and you should go through and fill in these steps just a little bit. So why has this become 12ths? Because I need to combine 4ths and 1/3. And how does this become a positive 8/12? Well, this, you add the additive inverse here, a positive 2/3 x. And so this is going to go away, but you have to add that positive 2/3 x to this side, and positive 2/3 is the same as a positive 8/12. And 1/4 is the same as 3/12. Combine them, you have 5/12. Use the multiplicative inverse. So you end up with 96/5. And here's a way that you can simplify 96/5. You know that 100/5 is 20. 100 divided by 5 is 20. There are 20 nickels in a dollar, for example. So that means that 1 nickel left, or one less, or 1 group of 5 less, is going to be 19. 95 divided by 5 is 19, and you have 1/5 left over. So this is going to be 19 and 1/5, and 1/5 is the same as 2/10. So now to figure out what that volume is, plug this time into either equation. So 19 2/5 seconds times 1/4. So every second, 1/4 of an ounce is gone. So 19 2/10 seconds. And here I'm using a way to mentally calculate what 19 2/10 force is. So I pull out 16 force. I know that that's 4. I'm left with 3 2/10 force. Well, 3 2/10 divided by 4 is 8, so that's going to be 8/10. So -4 plus 12 is 8. And you have a -8/10 to take away from that 8. You're left with 7 2/10. I'm not going to go into this detail for the rest of them, but I just want to use this as an example. So for the next one, -1/3 ounce per second. Set the two equations equal to each other. Move the -2/3 over to a +2/3. Remember, you're adding the additive inverse here. Combine the x terms, 2/3 x plus a -1/3 x, multiply by the multiplicative inverse. So 8 either divided by 1/3 or 8 times 3, 24 seconds. Plug that into either of the equations, and you're going to get 4 ounces remaining. And finally, the last one. So -2/5 ounces per second. So this one I did include changing it to the common denominator of 15ths. So 2/3 is 10/15. 2/5 is 6/15. Ends up with 4/15. Multiply by the multiplicative inverse, 15 force. 8 divided by 4 is 2. 2 times 15 is 30 seconds. Plug that 30 seconds in. So 2/5 of 30 has to equal 12. In this case, a -2/5 is going to be equal to a -12. Well, 30 divided by 5 is 6. That's 1/5. And 2 of those 6's is 2/5. It's a -12 plus a +12 is 0 ounces. It's useful to look at the graphs, look for some relationships, look for some patterns, and gain an understanding of what's going on. So let's compare Diego with Lynn's first rate of a -1/4 ounce per second. So if I'm going to zoom in on these two. And so for Diego, he's drinking at 2/3 of an ounce per second. So that's a -2/3 of an ounce. That's right here in 1 second. And that's the same as 2 ounces in 3 seconds. So here's the 2 ounces and here are the 3 seconds. And then if you look at Lynn, she's drinking at 1/4 of an ounce per second. So here's the 1/4 of an ounce, so much slower in 1 second. So then if you look at the 2 ounces, it's 1 ounce, 2 ounces in 2, 4, 6, 8 seconds. So here's 1 ounce in 4 seconds, 2 ounces in 8 seconds. So if you can compare the two, Diego's at 2 ounces in 3 seconds, and Lynn is at 2 ounces in 8 seconds, so much longer. So the faster rate, so this is 1/3 of an ounce per second. So I'm going to zoom in. This is Diego's. Once again, it's the same. So 2 ounces in 3 seconds. But now Lynn is drinking those same 2 ounces, the first 2 ounces, in 6 seconds. 2, 4, 6. So remember, it was 1/3 of an ounce in 1 second. That means it's 3 ounces. It's 1 ounce in 3 seconds. 1, 2, 3, and 2 ounces in a total of 6 seconds. Another 3 seconds here. So if you compare those two, Diego's drinking 2 ounces in 3 seconds still, but now Lynn's drinking those 2 ounces, the first 2 ounces, in 6 seconds, so a bit faster. It was 8 seconds, now it's 6 seconds. If you compare the last rate, this is 2/5 of an ounce per second. So again, Diego's the same. I'm going to zoom in, 2 ounces in 3 seconds, but now Lynn is drinking those 2 ounces in 5 seconds. Remember, the slower rate of 1/3 of an ounce per second, it took 6 seconds, and 1/4 of an ounce per second, it took 8 seconds. So it went from 8 to 6 to 5, and Diego's here at 3, 1 ounce, 2 ounces in 3 seconds. So again, 3 seconds to drink the 2 ounces and 5 seconds to drink those 2 ounces. So now I'm going to compare them one on top of each other. So this is 1/4 of an ounce per second. So it's 8 seconds. Then it's 6 seconds for 1/3 of an ounce per second. 5 seconds for 2/5 of an ounce per second. And then Diego is here at 2 ounces in 3 seconds. It's just useful to look at the relationships and compare. So here are all of them again together. Another pattern or relationship to look at is how long does it take to drink each milkshake at these different rates. That means that everything is gone. All the milkshake has been drank. So there's 0 volume left in each case. So to get to 0 ounces left, you have to have the opposite of what you started with. So this term right here has to equal a -20, and then add that to a +20, that's going to equal 0. Well, how do you get this to equal a -20? Well, what's the positive value? So 2/3 of some number equals +20, and 2/3 of x. So x is going to equal 30 seconds. And so now 2/3 of 30 is equal to a +20, which means that a -2/3 of 30 equals a -20. So this is going to be -20 plus a +20 is equal to 0 ounces left. It's the same over here. So this term right here has to equal -12 ounces because it's -12 plus +12 equals 0 ounces left. So a +12 is 1/4 of some number equals +12. So 1/4 of 48 equals +12. That means a -1/4 of 48 equals -12. So this becomes -12 plus +12 equals 0. Same here. This has to equal -12. So a +1/3 of some number equals a +12. So 1/3 of 36 is equal to 12. So a -1/3 of 36 equals -12. So -12 plus that +12 equals 0. And the same over here. So this has to equal -12. So a +2/5 of some number equals +12. So this number is 30, x is 30. So a -2/5 of 30 equals -12. So -12 plus a +12 equals 0. And finally, if you compare the rates, what's a comparison of each rate? What's the fastest? What's the slowest? Change each of these to a decimal value in the end. So if this is 12 ounces in 48 seconds, remember this was a -1/4 ounce per second. So it was 12 ounces, took a total time of 48 seconds. So it was 12 ounces in 48 seconds. So this is the same as 1 ounce every 4 seconds. I'm going to change it to 60ths. I'll tell you why in just a second. But then if you change that to a decimal value, so the slowest rate is 25/100 ounces per second. So a 1/4 of an ounce per second. That's really where we started at, 1/4 of an ounce per second. So the next one, the next fastest rate is 12 ounces in a total time of 36 seconds. That was the -1/3 ounce per second. That's 12 ounces in every 36 seconds. Change that to 60ths, because that's the common denominator between 4 and 3. This works out to be 20 60ths, which is the same as 2/3. Which is the same as 1/3. So that's 33/100ths of an ounce in 1 second. So a little bit more. The fastest rate that Lynn drank, that was 12 ounces in 30 seconds. So that's the same as 2 ounces in 5 seconds. So the common denominator, once again, is 60. 4 times 3 times 5 is 60. So this is 24 ounces in 60 seconds, or a minute. And change that to decimal, it's 40/100ths of an ounce per second. But notice these are all a minute. So this is 15 ounces in a minute, 20 ounces in a minute, 24 ounces in a minute, and finally Diego drank at 40 ounces in a minute. So this is 20 ounces in 30 seconds. So that's 2 ounces every 3 seconds that he drinks. The common denominator is 60, so that's 40 ounces in 60 seconds. And the decimal value is 66 hundredths of an ounce per second. So it's useful to look at these relationships. This is the slowest, this is faster yet, and Diego drinks at the very fastest rate. The reason that Diego and Lynn finish at the same time for 2/5 of an ounce per second for Lynn is because she's starting with less, 12 ounces compared to 20 ounces.